This lesson goes over factoring the difference of squares. The first thing to look at is the features of a polynomial which has the difference of two squares. First of all, difference means to subtract, and therefore subtraction must be present. Additionally, there must be two perfect squares. So when we look at what this would look like, we can see that we have difference, and we also have two perfect squares. So what would the difference of squares look like as a trinomial? The first and third terms would be perfect squares, and the second term would be equal to 0. So we can see we have the two perfect squares. We still have our difference happening, but now we also have a middle term, a second term, where we have 0b. But why include a variable with a coefficient of 0? Thus, instead of doing that, we write it as a squared minus b squared. The main steps for factoring the difference of two squares. Step 1. Determine the square of the first term. Our first term, when we look at the initial formula of a squared minus b squared, is the a squared. Therefore, when we need to determine the square of the first term, we look at a squared. A squared equals a times a, or the square root of a squared equals a. Step 2 is to determine the square of the second term. The second term is b squared, and b squared equals b times b, or the square root of b squared equals b. Step 3 is to write it in factored form. So you write out your parentheses, place a at the beginning of each of the parentheses, and then b at the end of each parenthesis. And then finally, step 4, add in alternating signs. The subtraction sign goes in the first one, the addition sign goes in the second one. So let's look at some sample problems. In the first problem, we have x squared minus 25. Looking at our initial steps, we want to first find the square root of x squared. And that is our first term. Then secondly, we want to find the square root of 25, and that equals 5. Our step 3 is to write our parentheses and place the information that we have determined inside of the parentheses. And then finally, we just need to do oppositional or alternating signs. So we have subtraction in the first one and addition in the second one. It is always best to check your work, so we multiply our first set and we get x squared. Our outer, and we get 5x. Our inner, we get negative 5x, and our last, we get a negative 25. If we were to combine like terms, we would see that the 5x's would cancel each other out, and we would have x squared minus 25. Therefore, our factored form is x minus 5 and x plus 5. Now we will look at problem 2. I'm going to rewrite problem 2 into a little bit more of an expanded or factored out format to help us factor out the actual polynomial. So first I'm going to start with looking at the 9, and 9 is 3 squared. Then we have our x squared. We have our subtraction sign, and then 16 is 4 squared. This helps us because it does tell us what needs to go into each of the parentheses. If we look at what the square root of 9 was, we would see that that is 3. And so I'm going to go ahead and place that at the beginning of each of these parentheses. I then also have x squared, and so the square root of x squared is x. So that's going to go right next to the 3, and it's going to go in each parenthesis. Secondly, we look at the 4 squared, which would equal 16. So 4 is going to go into each of the parentheses, And lastly, we want to have alternating signs. So we have subtraction and we have addition. When we check our work, we will see that based off of multiplying and distributing through the FOIL method, first, 3x times 3x is 9x squared. Outer, we have 12x. Inner, we have negative 12x. And last, we have negative 16. Again, our middle like terms will cancel each other out, leaving us with just the 9x squared minus 16. Now let's look at our third problem. We can start looking at the steps a little bit faster. So I'm going to go ahead and write our parentheses to initially start us off. The square root of x squared is x. We then look at our second term. The square root of 121 is 11. And lastly, we're going to put alternating signs, a negative and a positive. So we just need to check our work. X times x is x squared. 11 times x is 11x. Negative 11 times x is negative 11x. And lastly, negative 11 times 11 is a negative 121. Our middle terms, which could be combined, would cancel out, just leaving us with x squared minus 21. Our work is correct. Okay, let's take a look at problem number 4. Problem number 4 is going to be similar to how we solved problem number 2. So I'm going to go ahead and I'm going to write out my parentheses. I'm then just going to look at the very first term, and I have 4x squared. So looking at my coefficient of 4, if I were to find the square root, 4 is a perfect square, so the square root is 2. I then look at the x squared, and the square root of x squared is x. Then I'm going to look at my 9, which is my second term, and that has a square root of 3. Lastly, I put in alternating signs. Now it's time to check my work. 2x times 2x gives me 4x squared. 2x times 3 gives me 6x. Negative 3 times 2x gives me negative 6x. And lastly, negative 3 times 3 equals negative 9. My work is correct. I have checked my answer. Let's look at some more complex problems. This time, we have x to the power 4 minus 25. When we really think about that, it's like saying x squared times x squared. So the square root of x to the 4th power is equal to x squared. So in our parentheses, that's what would go in each one. We then look at the 25. The square root of 25 equals 5. So that's also going to go into our parentheses. And then lastly, we do alternating signs. Check our work. X squared times x squared gives us x to the 4th power. 5 times x squared gives us 5x squared. Negative 5 times x squared gives us negative 5x squared. And last, negative 5 times 5 is a negative 25. Our middle terms are like, and they would cancel out because one is a positive 5x squared and the other is a negative 5x squared. Therefore, our work has been checked, and we have the correct work. Let's look at problem 6. It's a little bit like problem number 5, except now we have a coefficient alongside the x to the power of 4. So first we're going to look at that coefficient, and the square root of 9 is 3. So we're going to go ahead and place that into parentheses. Then we're going to look right next to it at the x to the power of 4. And we might realize that x to the power of 4 is the same as saying x squared times x squared. And therefore, x squared should go right up against our coefficient in each of the parentheses. Lastly, we look at our second term, 36. 36 is 6 times 6, so our square root of 36 is 6. We place that in each of our parentheses, we place our alternating signs, and our work is complete. But we're going to go ahead and check our work. 3x squared times 3x squared is 9x to the power of 4. 3x squared times 6 is 18x squared. Negative 6 times 3x is negative 18x squared. And lastly, negative 6 times positive 6 is a negative 36. Again, our like terms would cancel out because a positive 18x squared and a negative 18x squared is equal to 0. So we're left with 9x to the power of 4 minus 36, and our work has been checked. On problem 7, we have two different variables. We have x and y, but it's no more complex than if we had numeric coefficients or different numbers. So we're going to think about it the exact same way as we would those. The square root of x squared is equal to x. The square root of y squared is equal to y. So when we looked at the rule that we learned at the very beginning of the lesson, we noticed that a squared minus b squared equals, open parenthesis, a minus b, close parenthesis, open parenthesis, a plus b, close parenthesis. So it's pretty much the same thing even if you have the x squared and the y squared. So we're going to place x minus y and x plus y, and that would be our final answer. If we went ahead and did the FOIL method, we would get x squared minus yx plus yx and minus y squared. Our middle terms would cancel each other out, leaving us just with that x squared minus y squared. Now we come to our final problem, 16x to the power of 4 minus 9y to the power of 6. So when we have exponents, we have to remember that when we multiply them, it's addition. So when we look at this very first one, we have 16 for our coefficient. We know that that's going to be a 4. But when we look at the x to the power of 4, even though in previous problems we talked about why this is, when we think about it, it's x squared to the power of 2. And so we're getting the x. We're figuring out what that is. Okay, so this is going to be x squared going into there. Now we're going to move over to the second term. Our square root of 9 is 3. So we know that that's going to go inside the parenthesis. Our y to the 6th power is a little bit different. So when we think about y to the 6th power, and we want the square root of that, we have to think about the fact that that is like saying y to the 3rd power to the 2nd power. So our square root is actually y to the 3rd power. If we were to multiply those, y to the 3rd power times y to the 3rd power, you would add the exponents and get your y to the 6th power. Lastly, we need to put in our alternating signs, subtraction and addition. And of course, we're always going to check our work. So, there we go. First, 4 times 4 is 16. X squared times x squared is x to the 4th power. I'm going to kind of alternate colors too so you can see it a little bit better. So now we're going to do outer. So 4 times 3 is going to be 12. But then x squared times y to the third power is going to give us x squared y to the third power. Now we're going to go with our inner. Now we have negative 3 times 4. We get a negative 12. We have our x squared and our y to the third power. Then we're going to go to our final portion, which is our last. So we've got negative 3 times the positive 3. And that's going to give us our negative 9 and y to the 6th power. So we've got this long expression. We have to remember that we can combine like terms. So in this expression, our like terms are our 12x squared y to the power of 3 and negative 12x squared y to the power of 3. Those would cancel out, equal 0, and we get our 16x to the power of 4 minus 9y to the power of 6. And our work is correct. This concludes our lesson. I look forward to working and providing additional lessons regarding quadratics and factoring.